Hi, we're here with Jay Rajagopalan from PSG Biotech to talk about Flowmeters.
Hi, Jim.
So can you give us a little idea of what are the Flowmeter offerings that PSG has? I know you have quite a few.
That's right. I think currently in the market, PSG Biotech offers the broadest range of flow technologies in the single-use space.
Yeah.
We have the most advanced and the world's first plastic Coriolis Flowmeter developed for single use.
Quite exciting.
And then we have clamp-on ultrasonic flow meters, and we also have single-use ultrasonic flow meters as well.
Okay. And so let's start with the Coriolis and the polymeric Coriolis flow meters. So just a little bit about that. I mean, you're really the first ones to come with this. What's the range of those, or how big of flows or small of flows can you get in those?
So we currently make the world's smallest Coriolis flow meter in plastic, which measures from 2 grams per minute in the lowest end. Which obviously is available in size 1/8 inch.
Okay, so you have like a hose barb or something that goes on to?
That's correct. And then we have all sizes in between from 1/8 inch all the way to 1 inch in size. The maximum flow it can measure is 100 kilograms per minute.
Okay.
And the larger the size it gets, we offer it in 2 types of fittings, barb as well as mini TC fittings.
Yeah. Okay, very good, very good. And so when do people use that flow meter, I guess, as opposed to traditional flow meters or what they're doing?
That's right. So if you look at all flow meter technology, they basically measure velocity and then calculate volume. And as you know, the fluids that are used in the bioprocessing space, the fluid properties would change during the process.
So the density and
viscosity,
so on.
and temperature, etc. And traditional flow meters that measure velocity and volume, they don't really cater for these changes. And,
correct.
They have to be calibrated on specific fluid conditions, and the calibration accuracy would be valid as long as that fluid condition stays as is, which is not always the case.
Sure.
And in TFF, for example, the fluid would change the viscosity from the start to finish, could range from 1 to 40 centipoise in some cases.
Correct.
And some of these velocity meters can introduce errors up to anywhere from 20 to 40% in such scenarios.
Right.
Whereas measuring flow by mass inherently is immune to those changes.
Right.
So it's ideally suitable for applications in biospace.
Okay, and I think that's something that we cover in my chemical engineering classes and so on, just how to look at mass flow versus volumetric flow, and that is really the advantage of these Coriolis meters.
Absolutely.
Which, historically were in stainless, and now you've brought them into the polymeric world.
That's right.
And so on.
Yeah.
So, I mean, it must be a fairly, I guess, significant impact as far as what to do with the process, and this is the entire unit that then the electronics get plugged in.
That's right. So
from the single-use kit.
It primarily consists of 3 parts: a flow transmitter, which is, of course, it sits in a panel.
The electronics,
so to speak. And the sensor itself has just got a basic coil and a drive coil, etc. And all remaining parts are all plastic. It's got a memory chip which holds the calibration factor for that particular sensor size, and a mounting cradle to hold it. And since Coriolis is being a vibratory type of a product, it needs a strong mounting cradle, and that's not disposable. That's permanently installed.
So the single-use kit fits into that.
That's right.
And then you're able to.
And once you connect the sensor to the electronics, then electronics would read the memory chip and gets married to each other. So then there's no field calibration required whatsoever. You may have to zero the device. That's the maximum you have to do.
Okay.
And then you can start measuring flow right from the start.
Right. Okay.
Yeah. And then because of its technological advantage, it measures temperature, density, It can interpret volume flow. It's a multi-parameter sensor.
Very nice, very nice. So just to be clear, everything that the process fluid touches is a polymer?
That's right.
There's no metal in that?
There is one small metal piece which is actually measuring temperature.
Okay.
That's like 2 millimeter exposure.
Okay.
All other components that are touching the fluid are all polymeric in nature.
And so PSG has done all the qualification package, and the customers can get that information with different types of modes of sterilization and,
That's right.
and so
That's
on?
right. Primarily the sterilization modes that this product is tested for is gamma sterilization.
Okay.
It's not autoclavable, just to let you know. And we have done all the validation studies, and we have a validation guide as well available.
Well, I know it is something that's really changing the industry. I've seen a lot of these, especially like you said on TFF skids, and that's definitely something that we're looking at. The other flow meters, so the ultrasonic and those.
That's right. So we have clamp-on sensors, and that obviously it's very less invasive to the application and easy to install, and it's suitable for all non-braided tubes.
Okay, so silicone, TPE, those types of tubes that can go with.
That's right. That's right.
Maybe you can shed some light, because I know some of our clients have had some challenges. If you go from a TPE to a silicone tube and they're the same IDOD, do you need to do something else with the sensor?
That's right. So there is a tube-specific calibration is required for clamp-on sensors. It's highly media sensitive, as we know. The technology limits that. But the advantage is that it's ease of use, and you don't have to cut the tube or do anything. And once you qualify, and then we store those tube parameters in the device, and you can repetitively.
So when one's going to, let's say they use the meter in the morning on TPE, they would put in those parameters, and in the afternoon on silicone.
If they change it, and they can introduce a different parameter. Yeah.
Okay. All right, very good. That sounds very exciting. Are there any trends you're seeing in flow in the industry, or anything you want to point out from your experience?
That's right. I think the rangeability is really a critical measurement requirement these days. For example, if you're having a flow meter in the chrome application, it requires widest turn-down ratio, and that actually led us to develop and introduce a new range of Coriolis Flowmeter. It's a O32. We just launched it. It measures from 20 grams at the lower end all the way to 3,000 grams all in one device.
And it's the same tube?
Same tube. It's currently available in 1/4 inch and 1/8 inch size, two sizes. But it gives you the widest.
That's pretty large.
Yeah, pretty large, and with similar accuracy throughout the range. Yeah.
Okay. And what type of accuracy do you show with those types of things? What's the?
So at lab conditions, we're getting much more better accuracy, like 0.2, 0.3%. But what we specify to the customer is 1%.
Okay, so 1% of full scale
of the measured value.
Okay. Okay. Of the measured value.
Measured value.
Yep. All right. That's what I thought there. Yeah. Okay. Very, very, very good. Anything else you want to add?
So this all our Coriolis flow meters can also measure bubbles.
Oh, that's right.
Right. So you can get an alarm output by bubbles measurement. In some applications, as you know, bubble measurement is critical. And
are people able to use these and eliminate their bubble trap because they get the sensor? They get the sensor to
bubble trap. This is not going to eliminate the generation of bubble.
But at least tells you
it tells you what the bubble. There is a presence of bubble is.
Okay.
So I think what I would say is that currently the widest range of flow measuring options in a single-use processing. I think PSG currently offers the widest range. From 1/8 inch all the way to 1 inch, 2 grams per minute to all the way to 100 kilograms per minute.
Okay, so it sounds like a lot of options someone has with the flow with PSG.
That's right.
Very good, very good. Well, I'm glad you were here and stuff. So we usually try to in these sessions get a little other general things. So you must have you've had a very accomplished career and know your products very well. Would you give any advice for some younger students or people coming into this area? What advice would you give a young person coming new into the biopharm space?
So I think knowing the fundamentals thoroughly is very critical.
Yeah.
And once you know the fundamentals of the fluid mechanics and various aspects of the engineering, it's a paramount need when you're really getting into the process engineering. So you don't know when you will come up with some problem, and how you can adapt from what you learned and quickly give a solution.
Well, I think your device is a great example of that, because the whole concept of Coriolis Flowmeters, you have to go to the core physics into how you measure that,
That's right.
and the momentum going around the turn to do that, and then how that translates in getting the signal.
That's right.
So you do need to understand the bioprocess, but also the physics behind the sensor.
That's true. I think that's why I'm saying, like, fundamentals are so critical in solving the problems.
Very good. Very good. Well, thank you very much.
Thank you,
for,
Jim.
for coming here.
Thank you for having me.
Very good.
Thank you.
Thanks.